Good. Thanks for participating in my presentation today. I'm Johanns from Germany. My dialect doesn't sound like I speak French because we are a Montreal-based company, so I'm German. And yeah, let's get started. I'm presenting to you today the Dragonfly solutions. Dragonfly is a software company. And yeah, about Dragonfly, we are part of the Comet Group since 2020. And based in Montreal, as I said, one of 12 subsidiaries of the group is a Swiss group in Flamatt, famous for their X-ray solutions and plasma control units. And yeah, we are part of it and manufacture our software with 35 people in Montreal or Montreal. We say Montreal in Germany, but it's Montreal, you know. So. And history. So it's a historic place, so some history about our product here. Four founders created it more for the purpose in medical for organ segmentation, the first approaches of deep learning methods. And since 2015 we have the product called Dragonfly, and it gets normally delivered with every Zeiss radius system, for example, since 2015, where we started having our so-called segmentation wizard, the possibility of creating your own deep learning model. What this means I'm going to show you later on. 2020 we are part of Comet Group, and now we are more than 10,000 active users working with the software, mainly in research, R&D, and yeah, that's what we're going to see later on. So part of our business model is direct sales, about 50%, and the reason why I am here today and I'm happy to be invited is with our partners. OR3D, for example, and RX Solutions. So yeah, thanks to the OR3D team for the perfect organization and the invitation. Very perfectly organized, and I felt welcomed every minute. So yeah, we understand ourselves as a supporter in science and industry for development purposes, for visualization and analysis of your 2D, 3D and 4D data. And we, as a software, act more like an open toolbox that helps you creating your solutions. Sure, it comes with a nice, let's say, intuitive overview of functionalities, but we are not the software company telling you what to do with it. It's all possible there and very well documented online. So this is my favorite marketing slide. You can see a lot of buzzwords, unlock the secrets hidden in your 3D images, and wow, it's a super software. It's best in class, market leading, wide range. So this is a typical marketing slide, and I switched it a little bit into something typical Dragonfly applications. That makes it a little bit more touchable, but it's true. Our visualization is best in class, and the deep learning is market leading, and that's really true because deep learning is our expertise, and we are focusing very much on this strength we have. This is the go-to solution for the future in inline inspection and any analysis that have to be reproducible and repeatable, especially on complex data sets. We are not in the time where we have nice light mono material that we can shine through and everything's perfect. It's getting more and more complex. We have standard segmentation tools as well. I have a bunch of examples today, and everything is Python based. So we say we are kind of a very open software. Sure, some of our code is hidden, but most of it that is accessible for the user can be manipulated by the user itself to create own functionalities and plugins. And yeah, we can do analysis. So the segments we are working in is research and science with live food material and geosciences and museums, which might be not the highest interest for the audience here. The other one is the industrial applications, where we create workflows for semiconductor inspections or electronics inspections, energy storage like an auto executor for overhang calculation, that's very trendy, and additive manufacturing, metal casting and injection molding. I have lots of slides about the essential features, but I don't want to make it too much of boring slides. So I'm going to show you two examples, and then we come to the applications I have today for you. So the first thing is the analysis tool itself, what can we do with the software? So we have all the basic functionalities that you know from those software solutions. You can import CAD files, you can align them, build a false color image, you can do all the wall thickness calculations, you can play with the data. We have even an image filtering and reconstruction tool included. So if you want to resample your data sets, that's the advanced image filter here, or we can converse data, is it a word? Like watershed transformation, distance transformations. So that's kind of basic. But what is interesting is everything that opens up to the new buzzwords, AI, deep learning, whatever. You will see that in the past years, this is like, yeah, it's super, you need thousands of data. We just spoke about it, thousands of data. It's way complex to train. So we really focused on making this accessible for everybody and to learn it simple and not within hours and days. You can learn it within minutes. If you're interested, I can give you a crash course within 10 minutes to train your own model, a pore segmentation model on ring artifact and noisy data, and you will see how simple it is. I can do it today if you want to. So one of the examples is AI denoising. It's a tool that's it's called noise to void, implemented in the software. You don't need any training, it does it for you. So the thing is, sure, my favorite thing is to work with the pure data to train a model. But if it might be interesting, this is a potential we have here, and it's already established. The other one is super resolution. It's very famous in the world of research. Super resolution. Hey, you scan something within minutes, and it gives you the resolution of a scan of hours. But it is a critical topic, especially in the industry, manufacturing industry. Everybody's really not buying it. But I have an example here which kind of explains this, what it does. So basically you take, this is a lattice structure, 3D printed. Basically you take a high quality scan or multiple high quality scans, and then you take poor quality scans. And the goal is to find the best case in between. And this is what it looks like. So you take your well scanned model, apply it to the bad model, and then you get something in between. This is what the graphs show when it comes to the contrast. So it works. It is, I think, something that is okay in R&D. If you are in quality assurance of manufacturing, you might not be highly interested in that because you want to work on the real data. But what it opens up is, for the future, if you have a very robust model and you have your ground truth and trained it very well, and this is what we do in metrology, I'm a metrologist, this is what we do in metrology all the time, then you will get a very fast scan within a very fast analysis time, upscaled to this resolution to make your decisions. But at the moment, we are more in R&D environment. As I said, it's a critical topic. The other thing is the automation and customization. Yes, we can visualize. Yes, we can analyze. That's all in there, but what people really like is its openness, what I said. You can create your macros, you have an easy configuration, but you have open scripting, it's Python based. And I have an example for you what this means. So here in this example, I asked my colleague Hubert, working in Montreal. This is a scan of a ruby sphere, so you know this from like Cactus presented it, just a ruby sphere for scaling or something. And what was not existing in Dragonfly, it's sure coming from material characterization and life science, it was not available to calculate the distance from the actual sphere to a nominal sphere. So this functionality was not in there, and I asked Hubert to record how he creates this functionality within the software, and everybody can do it. So what he did is he created the perfect sphere, and then he was searching for the functionality, distance from plane, distance from cylinder, distance from sphere, not existing. And then, how can I, yeah, this way. And then he opened up his scripting operator. So the scripting operator, this is what we see here. He asks for one command. Wait, I want to show you that it is really in there. So what he writes is, look at this file, distance from cylinder. So he takes the operation out of the library of Dragonfly, says take the distance from cylinder and create it on a theoretical sphere. So, and then the operator, and this is four times the speed. Okay, we're not clicking all the time the wrong thingy. So 4 times the speed. This operator takes the script, checks it and validates it, and reorientates it to a calculation of a sphere. So this is basically what has been done in the years before AI and automatic scripting in a very long time. But here, all the work Hubert did took 5 minutes. So the example shows within 5 minutes, he's able to create a complete new functionality within the software on his own with a scripting operator in the background, and he just filled in the functionality to get this result. And now it's released in the software officially, but we are not a company telling you what to do with it. So the thing is, if you are interested in these functionalities, you can create all that stuff on your own. Sure, Python scripting knowledge is required to understand what's happening, but it is just to show this is not just your workflow-orientated software, it's your working horse when you want to have your individual tasks. And this is, yeah, one question.
One question. Is this...
It's good that a question comes from him.
Is the software growing with a community if somebody drops something inside?
I'm going to show you later on.
Okay.
So that comes to our unique features. So I summarized it a little bit. What I see in the communication with our partners and OEMs as the key elements of the software why they purchase it. We are really focusing on AI solutions. We see it's trending. It's not just trending, it's going to be the future solution. At the moment, more in science and research, but you know, we don't need to, it's gonna happen and it will come, and we are prepared for that. The tools for automated workflows are integrated in the software. So it's, again, it's open. You have an auto executor, that's how we call it. You have your hot folder. You can take a look in the hot folder every seconds, minutes. It takes the information, runs your macro, and then exports the results in the way you want. This visualization is more in a representative way, but if you are a service provider, you want to create attention for what you're doing, the visualization methods are super simple to apply with cinematic rendering. And I got a sneak preview into the new versions. We have photorealistic rendering in future. You can't find the difference between the real part and the scan. It's super crazy what's going to happen. We don't have complex modules. I'm sorry. We don't have complex modules. So that means you purchase the software and it has all included. The development, all the analysis you can do, the AI, it's all just one package. And the broad community. So we have, that's the thing what people are very happy with. Because as you can imagine, when you're not super high concentrating on workflows, you have a lot of questions when you have this piece of software in front of you. It's similar, I always say, like you have PowerPoint and you have Excel. We are a little bit more on the Excel side. This means you can do a lot with it, but you have to know where it is. It will change in future. We're working on it to be a little bit more intuitive on that. But in our community, we call it Dragonfly Social. It is a website where people from universities can exchange their ideas. Our support center is connected to it, so you find immediate answers to your questions if you don't pay for a support contract. And you have sample data, you can download the software there, and you have all the videos, the training material available there. So that's what people love. We have hundreds of videos for every purpose, and you can just redo. I think it's super important today. Sure, you can get your proper training. That's how software manufacturers and everybody makes money. It's a professional training, that's good. But if you just want to get a specific thing done, this is your tool. And now we come to the interesting part, the applications. I'm pretty sure there are, why did you check your watch? I just, it's 50%, okay? He got 35 minutes, so. So I'm not sure, this is a pregnant 42 embryo snail. I think, is anyone from life science here? No, good. So we're not going to focus on life science. And this is a concrete crack wall thickness analysis. So But so we start with we start simple. The repeatability. So why deep learning and what does it have to do with repeatability? I like this example we did with AM Power. They are like a additive manufacturing consultant in Germany, and they create magazines about additive manufacturing. What they did is a tool steel study. So they had 28 parts, different metal, different printers, different printing methods, and they printed those cubes. And we contributed to say, okay, we create a general AI model detecting the pores within a specific region to quantify the porosity and have it comparable. Because as you can imagine, especially here, you know, there are multiple CT manufacturers in the world, system manufacturers, and everything creates different quality. Maybe you have a different magnification, voxel size, so you need a very robust model. And this was the goal here, to create something that gives you every time the same value. Because if we compare it with the traditional way of inspection, we have this example here. We created 10 ROIs in this test block. And then we told 5 application engineers to do a manual way of pore detection. And then you have like varieties. Of course, it's a Monday, it's a Friday, it's a Stefan, it's a Tamara, and they are doing all the different analysis. Sure, there was machine learning, you can create a recipe, but it's still, your CT data are so much depending on the environmental factors that everything looks a little bit different. We have 65,000 gray values and they look a little bit different. So the interpretation of pores varies. And in this case, yeah, problem solved. We have an AI trained on it and it makes it very repeatable. Sure, it's very simple set, but it's the way it is. The deep learning model does everything the same way. And this is, when you think about it, you are a manufacturer of turbine blades or whatever. And then you have suppliers all around the world with different systems. So how are you making sure that the quality assurance divisions on all the other subsidiaries have the same result? And for that you need a perfect plan that is validated on your data to make sure it is segmented every time the same way. That's this example. And I like that very much. I think it's, correct me, Roberto, if you know this sample, maybe. So it has something to, it was done with RX Solutions together. It's an example of cell pose segment anything. So we moved from TensorFlow to PyTorch. Doesn't have to say a lot, but it means we have now a new way with an AI library in the background that is much more future orientated. And it comes with a one-click solution segmenting all the particles. As you can imagine, before it was a nightmare to get this, and now it's a one-click solution. It runs, everything runs offline. There's nothing in the cloud, and you get a clear segmentation of this. It works on an image within seconds, and it works on 3D data as well. So what we see here is, first we have the volume detection of the particles, and you get a pore distribution model as well. So it gives you the distances between each pore, and depending on the size of the pore, the colorization of the pore as well. You can do with those data whatever you want. So we have like an open library of calculations and what you want to have of this. For example, out of it. For example, you can get the analysis for your tortuosity, so the shortest pass through the sample or something like that. So all the operations are there. The other thing, it's my application because I just wanted to test it. I'm a metrologist, so I took that some of you might know it. So VDI VDE 2630, they're asking for the MPESD, PFPS, and MPEE, stuff like that. So this is a nominal part. You put it in the system, it measures the 16 spheres, and then it calculates the sphere distances. This thing is calibrated, so it references to a standard, and that means in the end you have a good scale of your scan data. So I just wanted to figure out, or to show, I presented last year at the Tosca, how we do it in Dragonfly. So we can run subvoxel surface determination, then we can capture all those different spheres, and out of the spheres we can calculate our distances. So, and with these distances you build like the average value, and then you have the scale of your real value. So that's how CT system calibration basically works. Everything looks a little bit different, but it comes to the same result. Every CT system manufacturer wants to have comparable data to show we are that and that accurate. And within this specification of the system, I think it was 5.9 microns L/75, we prove with Dragonfly this is within the spec. And then I compared it with another metrologic software just to figure out what are the nuances. Where is the way I did it different from the way another metrologic software does it? And there are differences. But what I figured out, and I show it in my methodology, is that the creation of the referential values from the software is a full surface detection of the sphere, where it gets a little bit tricky on the ceramic sticks. And what I did is I cut it away everything from the sphere. And when you see the deviations, it's an average deviation of 0.16 micron on a voxel size of 35 microns. So totally within tolerance, no problem at all. And this was just to prove the metrologic functionalities are within Dragonfly on a basic level, but the methods used are very comparable. Yeah, life science. I put it in because it's one application I really like. Look at that face. I mean, but it's dead now, okay? But we wanted to take a look at the nasal structure, but you all know life science. So nasal structure detected, deep learning model created. You can create a deep learning model not just based on the gray values. You can do it based on the orientation of something or on the size of something. You define on your own the classification, like small nasal structure, large nasal structure, bone. So that's just the example, and then quantify this data. But this is a little bit more now battery. So coin cells are a very good example because they're high quantity, they get manufactured a lot, and they have one problem, the separator foil. Because when they get pressed next to each other, the separator foil can break due to the particles inside. So what I did is here for this customer to measure create a deviation map. So you create a reference plane and then measure the deviations of this foil, for example. Or you can train a model segmenting the dense material, the less dense material, and the air. Train this model to have everything differentiated from each other, and then you can quantify the size of it. This doesn't look super sexy. In 3D, it is a bit better. So you have all the particles. You can measure the distribution of the particles, the longest distances, and whatever in it. Yes, automated battery. I mean, we did it because everybody did. It's overhang measurement. It used to be famous, like additive manufacturing was famous. It still is, sure, but so the goal is here, you have different measurement scanning quality, and you want to have a robust segmentation of the anode and cathode to measure the cathode overhang. And this is what the video shows, but I just want to highlight how it's how you can do it in the production line and how it is done in the production line. So in the end, you do your CT scan with whatever system, and then Dragonfly does the segmentation of the overhangs. You can train it very fast. It's not magic, and then you create the automated export functionality. So that's just for inline functions, and it doesn't necessarily have to be a battery. It can be any manufactured part. That's something I really like, and I already gave a sneak preview. The metal powder. So in additive manufacturing, it's all about identifying the quality of the powder to make sure that the printing process is solid. Especially the aerospace printing is kind of a tricky task, especially when you have the recycling of your material. You put it back into powder. So you want to make sure you have no foreign particles or something in there. So in this example, I have those examples with me, so if you want to take a look with me together, I can show it on my laptop. It's not super tricky. So this, if you do a manual thresholding segmentation of the particles, it's a nightmare. And if you want to work with erode, dilate or whatever to get it separated, you don't have the true value. The cell pose tool ignores the ring artifact you saw there and the noise. It does a clean separation, and it's a one-click solution, and then you can quantify it in 2D, and I have it in 3D as well. So it works in 3D, so you have everything smooth and separated from each other. It's a tool. You can download the software. You get a 30 days trial. If you know me, in your present things, you have my card. Contact me. I give you more time to test it. So it is really simple to apply. That's a good thing. One-click solution. That's what everybody wants, right? Yeah, and this is what it looks in 3D. So you have all the particles detected, and then you can quantify them. This is according to the volume. The 3D printed cube. That's quite a nice thing because sure, we have all the things to detect the voids. We have a manual Otsu thresholding process. We have an automated pore detection that works well for a first insight into the part. But I'm a big fan of training your own AI model. And you can add classes to that. You can say, hey, there are foreign particles in that. Can be compressed material or can be something else. So you can train your model based on the particles, the different shapes of porosities. Maybe there are cracks inside. So you can classify crack, pore, dense particle, material, outside air as you want. And it works with a simple painting. The methodology is really simple. And you can just paint it. And the result is that it captures everything, the surrounding air, the material, the dense part, and you can do the analysis of each independent from each other. Write a macro and then quantify it, export it. And the model works on every part you scan, so it's pretty nice. Yeah, and that's what the segmentation of the one thing looks like. And this is the 6 lab. I mean, 6 lab means I take the whole volume and put it in one layer. But it's nice to see from one plane where the dense particles are in this case. Or you make a 3D animation where you see these are the dense particles. I like the splitter functionalities like on the website, so it allows you taking a look at the part and taking a look at the particles in one time. Yeah, the casting part, I mean, it's about, that was a nice animation. It's about how to get a proper trained model. As you can imagine, I have one example for you. Yeah, I have 5 minutes. I have one example for you that monomaterial is super easy to use, but if you have multi-material, it's Bowser from Super Mario. It's like an enemy because you really want to get the pores out, but not take the artifacts into calculation, and that's pretty tricky. And this is what we did here. So you can quantify the data. You can cross-check functionalities and have everything you need to get everything above or below an area you want to have, or you create multiple classes. So to quantify the voids that belong in the part or maybe do not belong to the part. And that brings me to, I think, the last example. I call it AI multi-material surface determination. I can call it AI multi-material subvoxel surface determination if you want to. Marketing has another word for it, but it explains it quite well. If you have multi-material, and this is a multi-material part, looks nice here, so yeah, super shiny, but something is hidden in between here. So if you go all in gray values, you see a mess of air that has been visualized, but a plastic pipe as well. So this application is done with the RWTH Aachen, and we did it for Bosch as well. So it is, if you are checking the final product and you have multi-material, dense material, plastic, aluminum, and you want to get a pore segmentation out of it, this gets really interesting because take a look here. I mean, you have everything shining through, then you don't see it on the monitor here, but there are small pores inside. And you want to get maybe reverse engineering, so you want to get proper surface data, and you want to get the void calculation of the plastic pipe. So before, especially creating surfaces on that with a standard thresholding approach, no matter if you call it advanced surface determination, multi-material surface determination, it doesn't work because it's just painful. And what this approach means, first of all, AI. You create your own deep learning model, segmenting the different materials, like voids, the plastic tube, then this, in German it's called mother, but the thing you screw.
Insert?
Yeah, insert?
Insert.
Insert, yeah. The insert and the 3D printed steel part. So you create a class for everything, like the print, metal, plastic, pour, and then you let it run through your whole data set. So you have all the materials separated from each other. And this leads to the detection of your surface model. So basically, you use AI to capture the plastic tube and the porosities. Then you click on surface determination and you use it as a mask. So this helps, no matter if you have artifacts, to get a proper surface out of it. And that was basically the mission here, to get a clear pore segmentation and to have the possibility to extract surfaces out of it. And that kills the problem and is going to be the future. Yeah, that's 2 minutes. That's the thing in a nutshell. So for the industry, it's all about productivity and automation. How can we help with standard tools or with deep learning to get you into an automated approach of detection? Sure, the standard quality assurance topic, like we saw today, everything about does my part do what it should do and where are the errors? And yeah, we can handle large data sets, but I think that's pretty normal today. It does your job for the cost efficiency, and we can integrate it into industrial workflows. That's the industry topic. And for science, I think the flexibility and openness. So R&D people, OEMs are happy with the openness of the product because they can create their own solutions, manage it now multiple times. The methods are always state-of-the-art deep learning. You can trust us. This is our main focus. That's it's like RX said, their focus is CT. We are a CT system manufacturer. Our focus is following the trend of AI segmentation. The visualization, it's going to be really crazy. The new tools are going to be beautiful. Everything is recorded. So the logging of all the functionality is tracked, important in aerospace. And the community. The thing is, students are allowed to use the software for free. We have a really huge fan base in universities, and they are exchanging information via Dragonfly Social. And this leads me to the availability of the training material, YouTube channel, and I promised my colleague to show it all the time. You have it in your bag, so you don't need to scan it. This is my colleague Alex, and I just want to see his smile. He says, William, paleontology inspiring materials engineering, I love it. He would never say that. He's totally marketing, but I told him when I saw the video, I will always show it. So that's just it. That's it from my side. Thank you.